Okay, Assalamualaikum and good afternoon. Uh, I hope you are doing well. You can hear me and
Yes, Doctor.
Yes, Doctor.
do
Waalaikumsalam,
you
Doctor.
do you salam, do you hear some fan noise? Ada dengar tak bunyi kipas? Ada.
Tak ada.
Tak ada kan?
Okey je.
Okay, so aku seorang dah dengar ni. Okay, tak apa. Aku seorang dengar apa. Okay, it's good to see you again. Kenapa saya cakap macam tu? Saya sebenarnya, I think some of you maybe know, saya dah di-infect COVID hari Jumaat hari tu. So ini ada hari the fourth day. So unluckily today my my family pula kan, yang lagi 3 orang pun positif juga. So diorang baru nak start demam lah. So saya alhamdulillah saya dah makin bagus. My condition is getting better, but my kids I think temperature is getting higher lah. Tapi still controllable lah. However, we still need to go on. Life must go on. So kelas tak boleh nak cancel. So I still need to proceed. Okay. Right. Saya rasa semua okay kot. Jaga diri elok. Sebab tak tahu kena kat mana kan. So dah kena tu, itulah. Redha lah. Macam mana kan. Okay. I think I want to do some reflection from the last week class, because we have already passed 1 month, 1 week, and 1 week after our last week's class, since we didn't have class on the Wednesday, and let me reflect it back about what we have done, what we have learned about the PV cell characteristic. Okay, when we talk about the PV, this is the main. So this is the PV cell. I mean the IV characteristic, the most important IV characteristic for any solar cell or solar module. Okay, where the x-axis is voltage and the y-axis is the current. And then there's a second axis of the Y also. They have it shows the value of the power, where the power you can easily derive from the P equal to V multiplied with I. So you can directly multiply with that, then you're going to get the knee voltage, or the, what you call that, is the PMP value. So this is the PMP value lah. You can get this kind of values when you multiply the value of current and the voltage together. Then you are going to get this curve lah. Okay, this curve where this is the VOC, the maximum voltage for the solar cell, and this is the IAC. Okay, mean IAC values here, where the V is 0 lah. So the IAC is the maximum generated current. Okay, at the place where the V equal to 0. Boleh dengar saya betul kan? Betul kan dengar saya
Dengar tak?
Yes, Doctor.
Okay. Saya dengar kipas dalam bilik ini, jadi mengganggu sikit. So, kalau korang dengar okey lah kot, biar saya seorang je lah berhalusinasi. Okay. So the maximum power tadi, the maximum power PMP is produced when the V equal to VMP at the point where the current is IMP lah. Actually it's here, then this value at this point lah, which is at this point lah. When we produce the P, so this is the maximum value for the power. Okay, it's not about VOC multiplied by IAC. It's different thing, because VOC multiplied by, at the time voltage is 0, and for the IAC at the time the V is 0, so it's not the maximum one. The maximum is where the IAC is slightly lesser than the IMP is slightly lesser than IAC, and where the VOC is slightly higher than VMP lah. Totally depends on the device. Okay. Alright, again, another value is very important in the, after we get the IV curve, we can simply get the value of FF. Once the IV curve is obtained, the rest becomes very easy lah. Very easy, just because everything derives from that IV curve. For example, the fit factor is coming from the ratio between the IMP equal to VMP, which is this is a PMP, and the value of the ISC, the maximum current multiplied with the maximum voltage, the VOC. So the fill factor is the ratio of the PMP to the ISC multiplied with VOC. They write here typical values of fill factor is between 0.6 and 0.7. But if we compare to the maximum value, the higher is better for fill factor lah. If they're looking for the fill factor, the typical value maybe around 0.6 to 0.7. Then after that, once the factor is attained, then the rest is the conversion efficiency. This is the efficiency that written in the datasheet, but that datasheet is at the standard test condition. But by default, the equation for conversion efficiency, I think everyone knows P out over P in. But for the PD case, so it's the PMP. It's actually the PMP value over this is the irradiance, the instantaneous irradiance. If we talk about the standard test condition, so the irradiance should be 1000 lah, kan? STC. If we talk about the NOCT conditions, at the time the irradiance is 800. Everything is written in the datasheet, so no need to worry. And then here come the A. What is the A? Is the active area of the cell. Active area of the cell lah. That's why the efficient, what we call that? The smaller the size is, the efficient the device are. You understand? If the size is getting smaller, means that this part is getting smaller and the total of conversion efficiency is getting higher lah. In other words, the most ideal solar cell in our mind, for example, we have this kind of palm size, your palm size or your finger size, but it can generate a lot of energy, it can generate a lot of power. So that is the most ideal solar cell that we are going to. In the future, I think maybe I'm not sure about another 10 or 20 years. Maybe we can generate certain watts of power by using the size of hand or our hand, palm. Our palm hand, tapak tangan. Bukan tapak tangan tu saja, kita dah boleh generate several watts. So that is the most, what we call that, most desirable characteristic of PV cell that we as a human want. Okay. Even though we cannot compete with the nuclear based energy, like I mentioned before, I think I saw some. I found some picture that I took when I went to the apa nama tempat saya pergi tu, Pusat Sains Negara. Pusat Sains Negara. I went to Pusat Sains Negara. I think around 4.2 grams, if I'm not mistaken. 4.2 grams can generate several kilowatts of power. Several grams can generate several grams of uranium, cesium, or any plutonium, the nuclear material can produce 1,000 watts of energy, of power. But for the recent technology, for the case of PV cell, I think that 20-something%, 30% of efficiency lah. Now we are getting that kind of value. Okay. So other than this equation, so it also can be written as this, where the fill factor ni go back to here lah. Okay, go back to here. Okay. These things can be easily calculated or estimated after we get the IV curve lah. Okay, after we get the IV curve. Okay. Any question? Until this level, any question? Not yet. Jamadil Akbar, any question?
No, sir.
No, not yet. Okay. Uh, Owi Safika. Any question?
No,
No.
sir.
Oh, so I proceed. Okay. Okay. Start from here. We try to throw out all of our misunderstanding. What I mean about the misunderstanding, that term misunderstanding means that we always think that the higher temperature, if we feel very hot, then the performance of the PV module will become better and better. It's actually different. It works in the opposite way. Okay. So PV output, power output of module depends on number of cells. Everyone knows. Number of cells. So apparently the 100 watt, 250 watt, 400 watt, now 750 watt. Of course lah, the size of the module itself is getting bigger lah. Why? The number of cells are increasing, of course. Number of cells. Each cell can give certain voltage kan, certain voltage. But because it's connected in a series, then becomes bigger lah when the watt is getting higher. Okay, that's logic. Okay. Then type of cells means that let's go to the very conventionally used the solar module. We know already mono poly and monocrystalline and polycrystalline. So that is massively and what we call that extensively used all over the world. Monocrystalline and polycrystalline silicon. Alright. Then total surface area of the cells. The higher is the area, actually can produce more energy, but at the same time, in terms of efficiency, there is different. There is a trade-off between that. Dia akan ada trade-off lah kat situ. When if the size is only getting bigger, but the output, the generated power is not much, so that means that cell is not that efficient. Like I mentioned just now, the ideal one that we all humankind wants is we can generate several watts of power with just a palm size of our hand. A palm size of our hand, just with the size of our hand, our palm. But can generate watts, several watts. So that is what we want. To standard ni manusia buat lah. Or with the size of our finger. Okay, our finger can generate several watts of power. That is what we want. We always want more. People want more. Desire more. Okay. So, okay, this is the factor. Okay, the power output. Okay, the power output of a module changes depending on, there's two factors here. One is the amount of solar radiation. The second one is the temperature of the module. Okay, I repeat. The amount of solar radiation is the most commonly, what we call, commonly, apa nama tu? Solar radiation is our friend lah. It's our ally. But the temperature is actually not as our ally. It's our enemy. Not the enemy lah. I mean uh, the negative factor to the performance of the solar module is temperature. Okay, it's actually the temperature. That is why here comes the very recent solar farm, floating solar farm, for example. That's one of the reasons, because of the water may have to cool down or to reduce at least the cell temperature. That is why they're doing the floating solar farm. One of the reason. Another one maybe because of the space. Okay, because uh, people are using most of the lands. eh? People are cutting down all the trees on the hills, mountains. We are cutting down all the things uh, to do the installation of PV, for example. But when we install on the surface of the water, so because most of the cases we don't really use them, we don't really use uh, because the sea or the lake, is very very wide. So if we can utilize it above the surface of the water, generating energy on the top of the surface of the water. So that's one of the what we call good solution to not to touch more to the land. So, kita gunakan the surface of the lake kan. So itu lebih, bagi saya lebih efisien lah. Okay. So effect of solar irradiance, current output of PV module is highly dependent on irradiance. So the higher, if you look from the below curve to the upper curve, so 200, 400, 600, 800, 1000. Clearly from here, the higher the irradiance we obtain, the higher the generated current, the higher the current is generated. Macam tu. Sini Okay. So, we need more irradiance lah. We need more sunlight. We need more sunshine duration in order to generate higher current for our PV modules. So that's very clear. Okay. Contrarily, voltage output does not change dramatically. Yeah, change maybe from 20 to 21 or 22 point something, but it's not that significant lah. It's not that significant. It still change, but it's not that significant. But the most significant one is the current lah. Current. So if the sunlight is blocked by the cloud, you can see the drop of the current significantly. Okay. Power significantly increases with the increase of solar radiance because of this current. The current is the radiation is getting higher, then the current is highly generated, which leads to the increase of the power also. Okay. So positive lah. So this is the positive factor. We are looking for this. Okay. Of course. Anyway, because solar, sunlight, sun energy kan. Of course we need exposure of the direct exposure of the solar. I mean from the sun. Okay. That's why the shading is one of the enemy also. So we need to have, if you want to install the PV system on top of your roof or near to your, what we call that, land, not land. Kalau rumah tu dah ada tepi-tepi halaman tu kan, make sure the place that you want to install will not block by the bricks. For example, the buildings, your houses, any trees or nearby buildings for whole the day. You need to make sure, you need to confirm. The easiest one, if you use the solar pathfinder lah, like I told you, the solar pathfinder is the correct answer. But if you don't have the solar pathfinder because you are all budget kan, kita semua budget, kita nak jimat, kita nak jimat. You kena tahu dah daripada pagi sampai ke petang tu matahari mana. Where is the panas petang, where is the panas pagi. So that is the one of the tips. Usually if you see some bricks, if you want to install at your halaman rumah kan, halaman rumah tu, for those who have who live in the house that have the small piece of land beside your house, if you want to install there, you need to make sure lah the awning, what you call, the awning, the roof is not covered the place that you want to install lah. There will be no shadow throughout the year, throughout the day. That's the thing that you have to be very sure lah before you do the installation. Though you don't have that kind of solar pathfinder or sun eyes application or device, it's okay. At least you know this kind of thing. You know where's the east, where's the west. You know the direction, and you know where's the panas pagi and panas petang. You know which year that the sun is covered, the sun is blocked by the building or so on. So you need to make sure lah. Okay. So this is what we are looking for, the exposure of the sun. The best way is to put on top of the roof. But again, you have to be so sure that your roof is compatible and suitable. Okay. Don't simply because you have certain budget kan, mungkin you menabung kan, PTPTN tu simpan sikit-sikit kan, tak makan, orang lain makan, kau simpan PTPTN, Masya Allah, simpan sikit-sikit kan. Puasa pun, buka pun dengan kurma je kan. Sebab nak beli solar ni pasal kan, tiba-tiba kan. Dan kau punyalah berjimat kan. Tapi but your roof is not suitable. Maybe always facing to the north, something like this, or facing only to the west, or east only. So it's not suitable lah. Though you have money kan, it's not worth. Okay. Boleh dengar saya? Ke saya cakap seorang? Ke saya shock sendiri?
Boleh Doktor, boleh.
Okey,
Alhamdulillah. Alhamdulillah, dengar. Alhamdulillah. Okay. Baik. Okay, saya proceed Right. The one about the temperature. Okay, effect of temperature. So the output of a PV cell or module depends on its temperature during operation. The module temperature gets elevated when exposed to the sun. Okay? When the ambient temperature getting higher. Ambient temperature tu suhu sekarang lah. Suhu yang bukan pada surface. Suhu biasa. Suhu ambient. Kita panggil suhu ambient. The ambient temperature is getting higher, right? Of course, when you touch any surface, you touch metal, you touch glass. For example, you just touch the glass of your windows, hostel or your house, and you can feel it is hotter than the ambient. Of course. Why? Because there is material there. So the cell temperature is the same idea, the same concept. It's not the same. For example, if you go outside, then 33 or 34 degrees, for example, like this season, because season is, we just passed the equinox. So the temperature maybe can go to 33 or 31 to 34 degrees. But when we touch the surface, for example, if you touch the body of the car, you touch windows, the glass of the windows, or you touch any metals, gates, and the stainless steel gate, the steel gate, you can feel it's much more hotter than the ambient temperature itself. So it's the same concept apply for the module also. That equation relates to this. Okay. So even though we feel that the temperature only 30, not that much lah. But if you have the infrared temperature, you just shoot face. Yang kau temperature tu yang kau tala kat kepala dulu kan, kita main tala kat kepala kan. Temperature tu you score your forehead kan, before you enter the premise kan. If you use that, then you can see sometimes 50 something degrees, 49 degrees, sometimes 55 degrees. I touch the solar cell with the temperature of the cell is 75 degrees, for example. It can go until that level lah. Okay, so that's why current marginally increase with an increase in module temperature. So ini current marginally or slightly increase with an increase in module temperature. For example, module temperature is getting higher like this. But voltage significantly decrease with an increase in module temperature. If you see from here, so getting it looks like more not hazardous, what you call that, more influential compared to this. No different. This one, even the radiant is getting higher, but not that different. It looks like accumulated in the first place. But for this case, 35 degree, 75 degree, 50 degree also, we can see for us, it's quite significant lah, the change of the voltage. The voltage will drop. Current maintain. Irradiant higher, temperature higher. Sekejap if the irradiance higher, temperature also higher, then we can get high current. High current is expected lah. Okay, current will not drop lah. Current will not drop, but the voltage will drop. So if we have only one module, It's not that significant if we have only one module. But if we talk about the series, a string of modules, in one string sometimes it can goes to 8 modules or 15, 17 in one module. So if each of the module decrease at 1 volt or 2 volts, for example, if you go total up, you get 10, then there will be a voltage drop of 20 volts. Macam itulah ibarat kata. Sebenarnya significant lah. Can goes until that level lah. Okay? Alright. So that's why temperature ni, the good weather is actually, we are not lucky. We are not in the 4 seasons country. In 4 season countries, during this season, during this equinox season, for example, in Japan, I used to give example about Japan because that it was my degree and my degree experience kan. So the best weather is when we can feel the ambient temperature. I mean the temperature, the weather temperature around I think 8 degrees to 20 something degrees lah. But we still can get the exposure of the sunlight as usual. Okay. If you close the door, for example, if you live in the house, you close the door and so the wind from the outside will not come in and but you open the your what you call it, your window is transparent and you can see the feel of the warmth of the sun you can feel inside your house without using any heater. You just sit in front of your windows that of course transparent, and you can feel the sunlight. But you don't feel the wind, the breezy wind, I mean the cool wind. That's the best one lah. So kau akan rasa memang shock gila lah. But once kalau if you go outside 8 degrees still, 10 to 12 degrees, you still wearing the coat kan, wearing the winter coat or the sweater. But if you live in the house, in your house, but with the in front of the transparent window, you can feel the heat, but you don't feel the temperature. I mean the temperature is not that very cool lah. Macam itulah konsep macam itulah. But for the 4 season country, when temperature is lower but the irradiance is higher, so it will cool down the temperature. It will cool down the cell temperature. So the cell temperature can be suppressed to lower, maybe around 25 degree and 26 at the ideal value. Then at the time receive a higher irradiance. So at that time, mostly at that seasons, the PV modules perform very well. Macam tu konsep dia. Okay. But it doesn't mean that we cannot use solar module. It's not suitable solar module in Malaysia. No. I'm not. That's not the meaning of this. We still can use the solar module because we have, our what we call that, our day quite long, and we are near to the equator, so we get a lot of sunshines, and our sunshine duration also quite longer lah, almost half of the day. So it's actually still suitable. But we are talking about the ideal performance of the PV module. The higher irradiance, the lower temperature is the best condition ever. Okay? Boleh ke? Zulfikar?
Boleh sir.
Boleh Radi, okay, Radi. Tuan Radi.
Yes sir, okay sir.
Okay siapa lagi? Mardiah, okay, Mardiah.
Okay, sir.
Bagus, responsif. Safrizal, ada soalan?
Tak ada sir, tak ada.
Tak ada Okay, yang lain tu nanti saya panggil. Nanti saya panggil Jangan risau. Kat mana korang? Okay. So, like I mentioned before, there's a relationship between the ambient temperature and the cell temperature or the material temperature, what we are focusing on the cell temperature. Yeah. So if you want to control betul-betul what technique we use for increase efficiency. Oh, okay. That's a good, good, good question lah. Maybe that's one of the reason they are doing the floating solar farm. I'm not sure under the floating solar farm tu, on the lake tu, what type of structure they have, or they just simply install just like that. But one of the reason we can cool the cell, we can help to cool down the cell by using the water, by using the water. I don't know, maybe they have sprinkler or something like that, or they automatically uh, splashing the water above periodically. I'm not sure lah. But sometimes it's not really good, and if too hot, then you pour some water. Sometimes it can crack, and I'm not sure about that. That the best way is to cool down the module, cooling down the module. For example, lah, I'm not sure now apply it or not, but if applied in certain places, it will cost a lot of money, lot of cost additional cost must be applied if we install this kind of material. I mean, not material, I mean solution. For example, we have the solar module, and I think this one is more to the mechanical lah. Mechanical, dia ada cooling. But not sure. Carburetor technique to cool solar module, the pipe inside passing through module. Macam ni ke? Carburetor ke apa? Cooling. Macam ni ke? Like that ke? Carburetor lain. Yang tu panggil apa? It's more to mechanical lah. Sebenarnya, actually, other than PV module, people, the PV energy, they also use we call it as solar thermal line. They can generate other than, because of the heat, because of the original heat that comes in to the module, they also can apply solar thermal lah. Maksudnya, they can also go for solar thermal. Other than the solar energy, the solar generated energy, they can also apply for solar thermal. My, what we call that? My ideal, for example, in order to cooling, what is the solution? For example, we put some sprinkler. You know sprinkler? Splash the water. Wah. But splash the water periodically lah. We have the sprinkler like in the ground, in the, what we call that? In the estate ke apa? Kan? So kindly English. I use English. For example, in the we use the sprinkler, then we splash the water. If they are floating solar farm, for example, they can take pump and put in the sprinkler water, sprinkler tu, and then they splash the water on top of the module. It may help to reduce the temperature of the cell. Okay, it may help to reduce the temperature of the cell. Using the water lah. If other than that, if we try to use the cooling like the, what we call, like the refrigerator or the freezer, that one is not applicable and it's not relevant lah. For me, it's stupid lah, because you need more energy to what we call, to cooling down the solar module. It's not relevant lah for me. It's not applicable lah. Okay. Okay.
Kalau letak heatsink je?
Again?
Kalau letak heatsink je.
Heatsink
Sampai belakang.
Heatsink I think it's not only the heatsink. It's actually the frame of the module also is comes from the aluminium already. But if you put heatsink tu, cost for the aluminium lah. The aluminium cost lah pula. Maksudnya if the size is 2 meters multiplied with 1 meter for each module, then if you try to do the heatsink for that, I'm not sure about the cost lah. The frame aluminium tu already cost higher kan. Then if we put the heatsink totally, I'm afraid about the cost lah. Maybe more than the value of the more than the price of the original module, I'm afraid lah. But good idea lah, good idea. You can try in your project Usually if we put heatsink tu, we patch together with the fan kan. Then the cooling is more efficient lah. So fan tu pula, that fan also need to pull from nowhere. You need to think about that lah. If everything, all the energy is taken from the same module, so the module will not have extra energy to supply to charge battery, for example. Because everything in the system man. So that's the thing that we need to consider lah. That's why that's one of the challenging. I think for the cooling, at the same time, the ideal one, okay, let's say we get higher irradiance, but we get higher temperature. So in order to get to lower down the temperature, so we are thinking about to install the cooling system. But the cooling system itself will need energy also to, for example, turn on the pump, turn on the fan, in order to in order to cool back the solar module kan. So at the end, maybe I'm afraid the what we call the net output of energy generated for each panel tu, I'm afraid nothing because we generate and we give to the cooling system. So it's very funny that one. But still, the thing that we need to think the thing that we need to consider, maybe in the future, maybe there's some people can come with the good idea okay. Okay, so the breaker formula for calculating the cell or module temperature during operation when exposed in the field is T cell equal to T ambient temperature, ambient maximum temperature during operation, plus with NOCT. What is NOCT? Nominal operating cell temperature is actually coming from the manufacturer. This is come from the data sheet. Okay, data sheet. Data sheet is written NOCT. And then, for example, the typical value varies actually. Sometimes 42, sometimes 47, like that lah. The value for the NOCT. Depends on the solar module. Depends on the data sheet written by the manufacturer. For example, Q cell may be different, Panasonic is different, Sun Power is different, like that. Minus 20 over 800 watt over square meter. Don't ask me when does it comes 20 and 800. It's fixed already, so just know this. I no need to know the root cause of this equation. It's a waste of time. We have the equation, we just use. Multiply with the G is the instantaneous irradiance at that time. Okay, instantaneous irradiance is the value of the solar radiance that are measured on that particular time when we calculate the T cell. Of course, the T cell will change time to time because every time the solar irradiance is not the same. Depends on the clouds, depends on the condition of the weather. It will affect to the irradiance. Everyone knows that. Even small kid know that. Okay, in the case where NOCT is not available, use T cell equal T ambient plus 35 degrees C. When you see there is no NOCT in the data sheet, you can simply take T ambient plus 25 degrees C. Same goes when you see for example, I forgot to give irradiance. In the question, I forgot to give you the value of irradiance. You can also assume this kind of things. Also can assume T cell equal T ambient plus 35 degrees C. Okay? Boleh? Nurul Ain. Is it okay? Nurul Ain?
Okay, sir.
Okay lah. Syahira, okay Syahira.
Okay, sir.
Oi, cepat respond. Okay. Alright. Proceed Okay. PV module specification. The datasheet provides technical information required to design and install PV array. Don't worry, we are going to look at the example of module specification after this. Yeah, Ganesh. Question. Ganesh. Okay. Useful for a consumer to compare different modules as it provides basic information about efficiency, rated power, and physical size. Of course lah. If we do window shopping, you do shopping in Shopee also. We are going to compare the specification between these modules and these modules. Of course lah. Same goes like you're buying other things also lah. You need to have the specification data. So this PV module specification. The physical output rated PV cell module are given a specific condition. These conditions are called as a standard test condition. After this, we are looking into it. Okay, standard test condition. So this is the value that I told you before. The item for the STC is the three things here. We are looking for the irradiance, cell temperature, T cell, and A mass, AM. Where the irradiance is 1000 watt over square meter, 25 degrees C of T cell, and AM 1.5 is the values for the standard test condition. Okay, basic value for the standard test condition. Okay. Okay. Maybe you understand already, but let's reflect. Okay, what is the relation between the cell and the module? Okay. So originally the small size of if from the PV module you can see the square kind of thing, right? The small scale size we call that as the solar cell, the small one. Then when several cells, solar cells, is connected in series like this, is actually connected in series. Connected in series. It's called as solar module. The correct term is solar module, not the solar panel. But we oftenly say solar panel. Solar panel is okay lah. It's not sinful if we use the term of the solar panel kan. But the correct term is solar module. Okay, solar module. Okay, solar module. That solar module depends 100 watt, 300 or 600 watt. It depends of the number of the cells connected in that module. That's why logically the higher the capacity it is, so the bigger lah the size of the PV module. That's logic lah. But in the future, if for example this is 200 watt. If in the future we can produce the same 200 watt with this small size of solar cell, so that is the most desirable, ideal characteristic of PV module that people want, that the humankind want. Okay. Then several modules connected in series. Several modules connected in series, it is called string, or we call PV string. At the solar farm, for example, near the Gambang highway, the LPT highway, then you can see when you are going back to Gambang, you can see, I think, at the right side of you, at the right side of the LPT, you can see that lot of strings. We call that strings. There's one line, but many modules, but they are all connected many. A lot of strings, a lot of PV strings. In one string, that string, the term of the string is the modules that are connected in series. How many modules? Depends. More than 2 is string. Maybe 2, 3, 4, 5, 6, 7, 8, 20 modules is connected in one line. In series, it's still called PVC, a PVC. So this is string. Okay, string, several modules connected in series is called string. Alright. Next, strings in parallel, it is called PV array. Array. If you see parallel, for example, you can see this kind of arrangement on top of the someone's house. Sorry, this is the house of someone. Okay, modules. This is modules. Okay, when we see this, you can simply say, oh, there's a PV array on top of the roof. PV array, maybe two strings. But actually, is it really two strings or one string? We don't know yet. Until we see at the back of the solar module, what is the correct connection. Why I say like that? It may become like this. Macam ni. Like this. Okay, like this. Plus minus. So maybe two strings. Or everything is connected in series. One string only. There's possibility. But at the first impression, if you see from the down here, you can see, oh, there's a PV array on top of that roof. It's not sinful lah. Okay. But to confirm that is it really two strings or only one string, you have to climb on the roof and see the back of the connection lah. You need to confirm with the connection lah. Everything must be confirmed with the connection. If the connection everything in series, though, so there are actually only one string but their arrangement looks like array. Macam tu. Right.
Sir.
Yes.
Kalau macam string punya type kan.
Okay.
Kalau satu part yang modul tu fully shaded, maksudnya terus tak dapat power je.
Oh, wait. Tu ada hotspot, bahagian hotspot. It's okay. Macam ni. When we connect in series, in one string kan, one module for example, let's say like in the middle, at the back, at the front, whatever lah, is covered by someone shades. Tahu shades? Bukan shades. Baju kan. Baju jatuh. Contoh, there's a condominium, very high condominium or apartment nearby to your house kan. One day maybe quarrel with the family there kan. So one clothes falling down from that house and it just fall right on top of your module. So at the time your module is covered by the clothes. I give example macam ni lah. Ni. Okay, clothes cover like this kan. Okay. What will happen? This phenomenon we call it as hotspot. Hotspot is not the internet hotspot. It's called hotspot. Okay. What is the dangerosity? What is the dangerous of this hotspot? Okay, when it close with this clothes, this part, the voltage drop. The voltage at that part, the voltage is very low because it's covered by the clothes or some blockage, leaf or something like that. So that voltage is getting very low, while the others is getting higher. So at the time, it looks like the flowing current. The current, all the currents now. For example, if this module 14 volt, and this one become 5 volt, and current will flow to the lowest potential, and this one maybe current become like this, but this part may be current reverse, and everything will be accumulated on this module. And the flowing of the current will be focused on that module because the module is very low voltage. Low voltage because of the hotspot. So at that part, it will become hotter. The temperature for that one is become greater, higher and higher. At the same time tu, dia akan reduce the whole generating current sebab ada reverse tadi, satu. Another thing, it will hit this module. If it is left for, if the temperature, if the weather is very hot, and you leave, you don't know, worst case it will burn, boleh burn. It can burn. And it can lead to fire, seriously. But not happen yet in Malaysia, I think. I didn't hear any case like this. So worst case hotspot ni, not only the reduce the whole current of the string, it will reduce the current and the whole current. Sebab the module is connected in series. One series, once everything current is the same, current is the same. So when effect like this, so once the total string current for that region will reduce, worst case too, it will become very hot. If you have the infrared temperature, if you shoot at it, you can get higher temperature. If quite higher, it can lead to the fire. Very dangerous. But not yet happen in Malaysia. I didn't hear that kind of case. Jarang lah dengar baju jatuhan. Tak dengar lah. We haven't heard about the clothes falling down from the sky yet. Kan? Just right under the module kan. We haven't heard yet. Macam itulah. Same like if too much dust. Too much dust tu, it will degrade the current. The net current also will totally degrade lah. Boleh ke? Siapa tadi tanya soalan? Aku pun tak tahu siapa tanya ni.
Boleh je, boleh.
Jawab ke? Macam itulah lebih kurang. Sebab tu we try to, that's why the importance of cleaning the module lah. Cleaning the modules periodical cleaning of the modules kan. There will be the cleaner who clean the module. But the problem is if the bigger the size of the solar farm, and the bigger the size of the solar farm, so more time will be needed kan to completely. Even though I think, for example, in Malaysia still okay kot, 50 megawatt. I think there's one we have discussed before, 60, forgot the size. 660 gigawatt in Kamuti, India. Very large solar farm. Can you imagine the same cleaner, for example, start to clean the first string of that solar farm. The first string, for example, 1 January. When he finished the last string, at the time the first string of the first string of the solar farm also already done. So the work is not not finished. But need to clean it frequently, periodically. If you just leave like that, that's the problem. Usually they check through the inverter lah. If there is the abnormality on the output power from the value shown in the inverter, if you see the abnormality of the output power, then they start to investigate to clean the module or so like that. If there's, I think by default, if there's no problem, they just leave it like that. If problem, then they try to solve or investigate or cleaning, do the cleaning. Sometimes they have the schedule already for the cleaning like that. Okay.
Doktor,
Yes.
ada tak macam sistem yang boleh detect contoh dalam satu string tu, satu modul tu ada hotspot?
Oh, jap. Dr. Shawal study he used the thermographic aerial using drone. Dia pakai thermographic thermal punya thermographic, and then you can see the difference of the temperature kan, image processing this. So they use the drone. Now recently I heard I have several students who work on solar company related. I get some input from them. They are now using the drone. Not sensor, they're using the drone. They launched the drone, so the drone is equipped with the image processing, the thermographic camera. So they can see the thermal difference there. So if the temperature is getting higher, so there's now, for example, the work for the research field, Dr. Shawal is using sending the information when there's different what we call this, the temperature different to each other, they will send the signal to the system, something like that. Now people are doing drone, using the drone already. Sekarang we use the drone with thermographic camera, thermal camera tu, thermal imaging, and then image processing and send the output and so on Sekarang dah banyak Usually to detect tu dia ada limitation for string tu lah. One string tu dia ada output dia berapa dekat inverter tu. That's why saying they look at the schedule kan. Dia tengok abnormality. Usually look at the abnormality. If looks okay, sometimes maybe shading or sometimes maybe there's a spot. But if they see between the different, there's no much difference between strings, okay, no problem. Gitu lah. Like that
Okay. Selesai.
Inverter lah, everything kat inverter tu, tengok output inverter tu. Tu paling senang nak trace lah kot. Banyak soalan ni. If anybody has experience in doing the internship in the solar company or solar project, ada tak? Is anyone experience? Tak ada? Ke belum lagi? Oh, ni ID 19 ID 19. Okay, ID 19 will go internship after this semester Okay. Any question? Any other question? Christopher? Any other question?
No, sir.
Setuju. Okay. Saya sambung sikit lagi. Okay. Chronologically from the negative factor of temperature to the module, chronologically from that, there's a coefficient, we call that as the temperature coefficient. The value of these temperature coefficients are stated and written in the data sheets. Okay, I can see almost all the modules. The proper brand of modules lah. Proper brand of modules means that the modules that you can, of course, you can buy from internet. People are buying from the internet, of course. But some module, you don't know the origin of that. The brand also is total. The name of the brand also already suspicious, kan? But with the claim, with the superb claim, that's why we need to be very careful lah. Usually in Shopee, also Alibaba Express, you can see a lot of solar modules that give you very cheap price. But when you try to look for the data sheet, sometimes the value is different, in the description is different, the number CD model is different also. You try to cross-check with the internet, you cannot find the real, which one is the correct specification. That's why when you look for the cheaper solar modules too, you have to make sure lah. One is the review, and you can see the original, the data sheet is there. You need to go there lah. You find the PDF one. That's better for you to buy the solar module that have the PDF specification data sheet. Please make sure that if they just paste in the description at the page, the Shopee page for example, they just paste in the description blah blah blah, they're writing, you cannot trust 100% on that. You cannot rely on that. You need to find the original of the data sheet. If not, you think it's 100 watt, it's actually not. For example, the IMP written in the description is 6.0, but when you try to look for the data sheet, you cannot find. And then when you bought it, when you try your system, only 4 amps. Why? That's the problem. It becomes after you get the module on your hand. Okay. So manufacturer provide the values of their module's temperature. These coefficient values are extremely important to determine corrected output values of current, voltage, and power when the module is operated at various climate conditions. Why is the temperature coefficient is very important? It's used for us. It is useful for us to calculate. We can calculate. We can determine the corrected output value of current, voltage, and power when the module is operated at various climate conditions. So we can calculate the corrected, or we can calculate the real operating condition of the module at certain temperature and certain irradiance. Okay, like I told you, mostly in the data sheet they are giving you the value of the STC, standard test conditions. What is the standard test condition? Standard test condition, that three things, 1000 watt over square meter, AM 1.5, set temperature to 35 degrees C, means that the module are tested under the lab condition. Under laboratory condition in the company, in the manufacturing. That's the testing that made based on that specs in the lab condition. Lab condition is not the real operating condition. It's not exposed under the real sunlight that you feel when you go to class. That's different. It's tested under the lab condition with the proper temperature, because your set temperature must be kept at 25 degrees C. That's why everything is controlled. That is the control environment. So the STC is the control environment. It's different with the real operating conditions. So that temperature coefficient is used to calculate the real operating condition of that module in certain period of time, certain period of irradiance and temperature conditions. That's why these values are very important. It is very useful for us to do the design of the grid connector system will be based on the temperature coefficient also. Everything is considered based on this. Okay, that's why you need to have the solar modules that have specification that clearly states what is the value of the temperature coefficient. Macam tu. Okay, not only limited to the current, also you can calculate for the voltage and the power case. So current, voltage, and power. Okay. Okay. Typically, the temperature coefficient of current, like this, is a tiny positive number which indicates that the output current increases marginally corresponding to the increase of temperature. Okay. Temperature coefficient, there are three. One is for the current, voltage, and power. Okay. They're written in, I think, the gamma. Sometimes they write like this lah. ISC. What we call VOC, PMP. So this is the meaning of temperature coefficient of short circuit current, open circuit voltage, maximum power. So that's the meaning of that. Okay. Okay. For the case of current, temperature coefficient for the current is a tiny positive value, tiny positive number. Tiny positive number means that for the case of the current, this current, there will be a plus value with the tiny value lah. But plus, why plus? We already agree. Current increases marginally corresponding to the increase of temperature. Increase plus lah. Marginally, that's why the value is tiny, very tiny. Increase of the temperature. That's why towards the increase of the temperature, current marginally increase. That's why the value must be plus. But with the small value. Okay. For the case of voltage, its temperature coefficient is relatively much bigger with minus value, which indicates that the output voltage decreases significantly corresponding to the increase of temperature. For the case of VOC, most cases for the standard polycrystalline and monocrystalline based solar modules, the value is plus. Okay, the value is plus. I think example 160 millivolt per degree C, maybe. For example, the value for the value for the opposite voltage, I mean temperature coefficient for opposite voltage plus 150 millivolt per degree C, for example. So the value like this. Okay. But I think for the current maybe 0.0 something. I forgot lah. I forgot the value. The typical value I forgot. Oh sorry. Plus lah. Negative. Sorry. Negative. VOC is negative. Sorry Same goes with the PMP. PMP also, most cases for mono and polycrystalline based solar module, the value for I think the typical value minus 0.5% per degree C. Tak apa, nanti we will discuss what's different between the millivolt and percent. So this is the value that we are going to look at it over and over again after this. Okay? Boleh ke Siti Nuraini? Siti Nuraini? Okay? Syamim?
Yes, sir.
Boleh?
Boleh.
Nanti this level okay?
Alright, beres, sir.
Beres Okay. Saya teruskan Saya proceed Allow me to proceed. Okay. Now we are going for the temperature coefficient factor. Okay. Temperature coefficient is this. This is the temperature coefficient. What is the temperature temperature correction factor ataupun temperature correction factor? Ftemp. Okay. Oh ni correction saya ni. Correction kot. Tak apalah. Okay, this gamma is temperature coefficient of parameter X, where X can be ISC, VOC, IMP, VMP, PMP. Means that anything IMP, ISC is okay lah. Means all equation for power, current and voltage are the same, but the difference is the value Okay, the difference is the value. This is the basic equation. But don't worry, we are going to do the exercise. We cannot simply understand. Oh, okay, understand. Just look at this equation. Khalas. Finish. I understand everything. No. We are going to look at the exercise after this. Okay. So I just give you the view of the equation that we are going to use after this over and over again. Okay. So this temperature correction factor. Okay, it is applicable for all parameter regardless it is voltage, current or power. Okay. I just want to ask, what is the value of T cell? How can we get the T cell? Pak tidur semua ni. Tanya siapa? Syuhada. Syuhada Maisara.
Yes, sir.
How can we get T cell? Where can we get the T cell? What is the value of T cell? Salah tanya.
TAMB tambah 25.
Boleh? Ambient
Tambah 25.
tambah 25 tu kalau dia tak ada G atau NCT. Dia ada equation panjang sikit. Apa equation panjang dia? Tambah 25 tu kalau the value for NCT or G is not given. Then you can assume 25 degrees C lah. If the value is given, so what is the equation? What? T ambient plus apa? Cepat. Syahira, kena backup dia cepat. mana ni senyap ni? Tidur. Syaira ke Syahidah ke?
Ya.
Cepat.
Kejap dulu.
Ramai-ramai dalam tu pun tak ada jawapan ke? Ayo. Siapa seorang lagi? Syahidah ke apa? Cepat lah. Sama pula.
NOCT.
University apa? Lepas tu?
Solat dengan 20.
20. Lepas tu?
Bagi
Lagi apa? No, not 80.
800.
800. Lepas tu?
Darat dengan G.
G. Okay. So that T cell is coming from this equation lah. Okay. TSTC how much? TSTC Nizaruddin. Naufal biasa bunyi ni. Tak ada bunyi lah ini.
Tak tahu saya ni.
Tak tahu. Puasa tahu. Sihat ke tu? Nampak sama bunyi lah.
Ya, Alhamdulillah.
Alhamdulillah. Apa tak tahu? TSCC. Aigu. Siapa? 25 degree C. Alamak. Boleh lah. 25 degree C. T cell is obtained from the T ambient plus NOCT minus 20 over 800 multiplied with G. TSTC fixed. It is fixed 25 degree C. Only one value. TSTC only one value. Remember Okay. Sikit ni. Lupa lagi. Right. Okay. Ini apa benda? Okay. Yang ini temperature coefficient factor, correction factor. Okay. After we know the temperature correction factor, temperature coefficient factor tu, then we are going to calculate the corrected output. I will write it as the real operating condition or ROC of the module in term of ikutlah I, V or P. Okay, so mean the question will ask you what is the real operating condition for the module that perform what the real operating condition of the module for the current short circuit current, open circuit voltage and the maximum power of the module, for example. That's the value of the real operating condition. So this is the value that we are going to calculate. Or what is the corrected output for the PNP, VOC and ISC, for example. This kind of value. Like this. Okay. Corrected value. Corrected of the ISC, VOC, IMP, VMP and VMP. It can ask you in any different ways. Not only current, not only voltage or not only power. But everything can be used with the same equation. But remember the value is not same lah. It's different. Okay. So, corrected. So this is what I call, for example, if I say ISC corrected. So, this X will be replaced with the ISC lah. Means that ISC STC. What is the ISC STC? You can refer to the solar module specification data sheet. Everything is there. Okay. So what is the FSPEM? FSPEM is the equation that comes from here originally. But for the case of the unit given percentage per degree C. Later we'll look at the example. What is the meaning of this? But the things that you need to know, the value for temperature coefficient, the units for if the unit of the temperature coefficient is percentage. If the value is percentage, then this is the equation that you will use. What is this? F is T. For example, I replace X with the ISC. Okay, ISC. So this is the ISC STC multiply with 1 plus, so this is the ISC. T cell, the previous equation, TSTC is 25 degrees C. Okay, so STC multiply 1 plus blah 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 blah. Okay, so this is the value for the percentage. Okay, let's stop. Kita fix kat sini. Yap, we move that to this slide. Okay, second case for the case of temperature coefficient for anything in the unit of whether millivolt, amps or watt. For example, so means this is the ISC lah. So this is the this is the VOC, and this is the ISC, and this is the PMP. For example, if this value are in voltage, amps or watt, you are going to use this equation. Okay, fine. What is the difference? It looks the same, sir. What is the difference? For example, I give the example ISC. X is the ISC. So this X also represents as the ISC STC. Okay, correct? The next is the plus. And again, this is the temperature coefficient for the ISC. Multiply with T cell, same like before, TSTC, 25 degrees C. So there's no difference now. It looks the same. It's actually different. What is different? And then you see here, multiply, and there is the one. There is the one here. For the case of percentage, values, no multiply here. Plus, but no one already. No one. Tak ada nombor satu. Nombor satu ni here. Tak ada nombor satu. Sekejap. Faham ke ni aku cakap ni? Duk sembang seorang ni, tak syok kan?
Faham, Doktor.
Boleh ke? Saya conteng sini lah Pun tak nampak. Okay, saya bagi contoh sini ISC STC. Saya terus sini Saya kira connected tu ISC STC. Multiply with 1 plus correct temperature coefficient for ISC, T cell minus TSTC. This is for the case value. This value is percentage per degree C. For the case of values, amps, ISC, STC still the same but plus. Plus no one. Terus ISC, T cell minus TSTC. Terang. So different way. This is different. And this is different. So there's different. This is a common mistake that made by all of your friends before. Maybe because of the time, you start to get confused. Now maybe you're not getting confused, but during the test time, pressure, everything, everything must be passed. I said, okay, another 10 minutes, or people are rushing. Even though it's open books, open internet, everything, but at the time the panic attack happen kan. So confused. Make mistake. Khalas lah. Khalas. Because you make mistake there, I think the all values can go to 3 marks lah, I think. For this one can go to 3 marks. The first equation. If the question is wrong for me, I will not hesitate to give 0. Seriously. If the equation is wrong. But if equation is correct, but the value is wrong, you can get plus for the equation, and the value wrong maybe half code. 1/2 per 3. Maybe you can get. Ya, Nurani, macam mana soalan? Dah buka mic tu, tanya jawab lah. Macam tu. Okay, jap. Any question? Oh, okay, we go last. One example. One example. We go one example. Now, before that, any question? Haziq, Muhammad Haziq. Muhammad Haziq. Tak ada. Irfan.
Yes, sir.
Any question?
No, sir.
Understand
Boleh,
okay,
boleh,
ke?
boleh.
Boleh ke ni? Tengok sikit. buat latihan lagi aku panggil nama kau. Siap ke? Ya, Hasif. Okay, Hasif.
Okey, doktor.
Okay
Okey.
Farhana. Sampai 2 buka. Okay, Farhana.
Okay, sir.
Okay.
Okay.
Ya, okay. Okay, kita pergilah kan. Kita pergi dekat exercise dia. Promise. Saya suka bagi promise. Promise itu. Alamak. Dah nampak belakang tu. Tak nak. Sekejap okay, sorry. Alamak. Okay, let's go with one exercise. Okay? Boleh je 10 to 15 minutes. Okay, 10 to 15 minutes. Promise as usual. Okay. The BP solar, ini bukan BP tu BP station, petrol station BP solar FX150B. Oh, ini very old school and very old stuff module, but it's okay. Just for the sake of the exercise. Operates with an average maximum ambient temperature of 35 degrees C at solar irradiance 1000 watt over square meter. Okay, so this is very clear and very straightforward and very boring question because very straightforward. We know already the T ambient is 35 degrees C. This is the T ambient, and then this 1000 watt over square meter is what? Is the G value. What is G? Solar irradiance. Okay, the solar irradiance value is 1000 watt over square meter. If the module is clean, determine the following. Okay, it's actually asking you to calculate the real operating condition of the PV module lah. Senang. Okay, that's the only thing that we are going to ask you lah. We give you the temperature, we give you the ambient temperature, and we give the irradiance. Then they give the kind of short circuit current, voltage output. What is that? Is the real operating condition. ROC, or corrected output of short circuit current, voltage at open circuit, maximum power output. So that's the meaning of this question. But this one's very super boring question, very straightforward. Too easy. Okay. What is the operating PV cell temperature? The first one is to ask you operating PV cell temperature. You remember already kan the equation? Ingat kan?
Yes.
Apa dia? T ambient plus NOCT minus 20 over 800 multiplied with G. So, How much is the value for the NOCT from this data sheet? What is the value of NOCT? Very clear and simple. But what is the value of NOCT that we can extract that from this data sheet? Super easy. Even my kids can do this.
47 sir.
Yeah, 47. It's here.
But plus minus for 2 degrees itu macam mana lah sir?
Good question. Okay. 47 plus minus 2. The answer is just ignore the plus minus 2 We just take the front one, 47 only. So throw it away. Okay, just ignore all the plus minus, throw it away. We just take the first value. So here is 47. So 47. So please calculate lah. Boleh calculate. Cepat.
Berapa tadi?
8.75.
Apa? Laju lah. Tak syok orang kawan ni. Apa nak tulis? Bagilah. Macam dulu aku tulis. T ambient plus NOCT minus 20 over 800 multiply with G. T ambient apa? 35. Plus NOCT berapa? 47 minus 20 over 800. G is 1000. How much? 50?
68.75.
68.75.
60.
Ah?
6.
68. Sorry. Puasa kan? Tak clear. 68.75 degree C. Don't forget the degree C Okay lah, until this level, even though you don't write the degree C, I still can okay lah. Maybe this semester maybe I start to become more strict If you don't write degree C, then I minus 0.5. Okay lah. Okay, 68.75 degree C. Izzuddin dapat tak Izzuddin? You dapat. Okay. Okay. Even though this one is writing like this, this is the schema lah. The schema. But for me, I don't like. Please, 68.75. My preference is 4 digits, 4 decimal lah. For example, if you get 4393 kan. So my preference is 4 decimal. 4 decimal. But if you calculate 68.75, you get the answer exact 68.75. No need lah to 68.7500. 00 no need lah. No need. Okay, just this one is enough lah. But in case you get this kind of value, 7439, so just write 7439. That is my preference. Okay, preference. Okay. Okay. Betul, senang. Super easy. Okay. Okay, short sikit Karen. Jeng. Okay In order to get the short skirt current, remember 2 values that you need to extract from this. What is this? Short skirt current, apa value yang perlu ada? You need to have the ISC/STC and temperature coefficient for ISC. So these 2 values you need to extract from the data sheet. So what is the value for ISC/STC? Cepat. Li Yao Meng. What is the value of the ISC/STC? Li Yao Meng. Ay. Makan Li Yao Meng. Third call. Yo. Divenya.
Yes, sir.
What is the value
Yes, sir.
for? Sorry.
4.75 ampere.
4.75. Again. ISC, yeah. Okay. 4.75 amps is the value for the ISC STC. Okay. Next. Next. What is the value temperature coefficient for ISC? What is the temperature coefficient for ISC? Ashraf Aziz. Ashraf.
Apa tadi, Doktor?
Value for the temperature coefficient for the ISC. Uish, tidur. Ashraf. Hilang lah.
ISC 0.065.
0.065 apa? 0.065
Temperature coefficient. Degree C.
0.05%. Degree C lah. Okay. Ingat ni kita nak bagi kira jap. Okay, 1, 2, 3. Okay. So, second one is the ROC of ISC. So, ISC ROC. I call it ROC senang. So, ISC STC. So, just now, we know the ISC STC is 4.75 amps. And the ISC, temperature coefficient for ISC is the 0.065 percentage over degree C. So, what is the equation that we are going to use here? That's my question. OE. 2 kali panggil nama OE ni. Which equation that we will use? Since the value for the ISC, temperature coefficient of ISC is percentage, so what type of equation that we will use for this case? Cepat. Dia ada 2 tadi kan?
Yang ada 1 sama.
Yang ada 1. Okay, yang ada 1 tu betul. Cuma sebelum ada 1 tu dia ada apa? Dia sama ada tambah atau darab?
Darab.
Confirm?
Confirm.
Confirm ke? Ya, betul. Lepas tu tambah. Ada 1. Habiskan dulu.
Tambah.
Jangan tutup lagi. Habiskan dulu. Nadat tadi.
1 tambah.
1 tambah. Betul? Teruskan. 1 tambah.
Opposite.
Cepat.
Yang bentuk macam di atas tu.
Apa? Tambah apa ni? Ni, apa ni?
T-cell.
Ni, tambah ISC. Lepas tu? Lepas tu apa? Kali.
Darab.
Tambah macam ni lah. Lepas tu?
T-cell.
T-cell.
Minus TSTC.
Okey. Baik. Dibantu oleh pensyarah. Dibantu oleh pensyarah. Okey. Khairul Ikhwan. Enggak ada. Syahrul Aiman.
Sir.
Apa dia?
4.75.
4.75.
Darab.
Betul?
Sekejap. 0.065.
0.065.
T-cell 68.75.
68.75. And then?
TSTC
25.
25. Okey.
Betul
ke?
Betul,
Betul kan ni? Betul ke? Saya tengok orang lain.
Bukan ke 35 sir?
Apa benda? Ulang balik. Bukan apa? TSCC ke? TSCC 25. 25.
Over percent. 100.
Over percent. Dekat mana over percent?
0.065.
Okay. Over 100. Over 100 lah. Over 100. Nah, check kira ya. Tak tahu betul tidak itu kira ya. Tuan Radi. Senyap lagi Radi. Mana Radi? Radi. Tidur lah ke? Nurwani Ahmad. Wani betul tak? Oh, Wani tak ada. No. Not Ganesh. Wrong answer. Dia cek orang ni. Okay. Okay, sekejap. Saya cuba ambil value ni lah. Value OE. 4.8851. Betul ke ni? Betul ke ni? Siapa dapat macam ni?
Dapat.
Dapat sir.
So dapat 4.88 tu? Saya nak 4 decimals. I want the 4 decimals. But you give me 4.88. If you try to do the 2 decimals, it becomes 4.89. Kan? Betul. Oh, tu bagi lebih-lebih tu. Ridwan tu. Lampau-lampau. Okay, 4 decimal only. Alamak, sekejap. Ni pun salah sebenarnya. Ni pun aku salahkan juga. Okay, kena satu. 4.8851 lah. Okay. Tahu kan? Boleh faham Do you understand? Because the temperature coefficient for the IC is given in the percentage. That is why we use this equation. Okay. Walaupun OE agak teragak-agak, tapi kira betul lah tu. Dia kira betul bawah ni. So 4.8851. In other words, logically, this value must be higher than the ISC-STC. If your value is lower than 4.75, your calculation is totally wrong. Why? Because the current will marginally increase with the increase of the temperature. So the value must be slightly higher than the original ISC-STC. Saya rasa dah lalang ni, kita habiskan terus ya. Okay. Last. Maximum power output. Okay. Last but not least. Okay. What is the PMP-STC? Sorry, tak ada. Lepas ni. But PMP-STC. Ikhman Nabil. Tak ada. Aish. Korang isi ini tak? Attendance. Did you fill up the attendance already? For those cannot fill in, cannot sign in the attendance tu, tak ada apa-apa lah. Cepat. Nabil. Tak ada Nabil. Izzat Imran.
Yes, doktor.
What is the PMP-STC? How much is it?
150.
150. Lepas tu temperature coefficient?
Temperature coefficient 0.065.
Ulang balik.
0.065.
Bukan. Oh, saya terskip ah. Sorry. Aish. Voltage dulu. Sorry. Voltage. Alamak, sorry aku tersasar. Delete. Sekejap. What's the VOC STC? Sorry. VOC berapa VOC?
VOC 43.5.
VOC is 43.5 volt. So that is the VOC. And then the temperature coefficient for voltage?
Tu 160. Plus minus.
Minus 160.
Oh, minus.
Minus 160 millivolt. Okay, sekejap. Kita lompat. Faham. Oh, shit. Okay. Cepat. Oh, 350. Okay, ROC of VOC. Okay, VOC, ROC. Okay, which equation that we use? Because here VOC is 43.5 volt and the temperature coefficient for VOC is I forgot apa tu?
Negatif 160.
Millivolt. Okay, which equation that we use? Orang lain. Siapa orang lain tu? Wani ada Wani. Daniel. Wani ada. Macam ada Wani ada. Tak ada.
Ya.
Ada pun. Tidur
Tak.
Cepat. Equation. Cepat. VOC STC. Lepas tu. Cepat.
Yang mana sih?
Ni. Aku tunjuk ni. VOC ROC equal to VOC STC. Apa equation dia? What type of equation that we are going to use? Kalau current tadi sebab value dia ada percentage, they use multiply F1. But this time the value is given in solid value, millivolt. So what type of equation that we will use?
Times with temperature.
Bukan. Tak. Dia sama ada multiply atau plus. Yang mana satu kat sini?
Oh, plus
Apa plus? Confirm?
Rasanya
Plus rasanya. Lepas tu? Plus apa?
plus 1.
Salah. Plus 1 tu tak ada. Dia kalau multiply baru 1. Dia kalau plus tu dia tak ada 1.
Oh yang ni. Oh yang tu. Apa yang bentuk V tu, simbol V tu.
Datang ni, gambar ni. Ni ke?
Betul.
Lepas tu?
Darab dengan T cell tolak T cell.
Itulah T cell tolak
tolak TSCT.
TSTC. Okay.
Yeah.
Okay.
Okay.
Tolong selesaikan. Siapa nama dia? Fakrul Izwan. .5 volt plus Fakrul. Cepat nak habis ni. Cepat nak habis. Fakhrul. Tak. Ganesh.
Yes, sir.
43.5 plus what?
Plus 160 over 100. Sorry, negative 100. Negative 160
Over?
Milli.
Milli, okay, over 1000 lah. Milli
So, yeah, 1000, sir.
Lepas tu?
Then multiply
75
minus
25. How much is it?
25. Tak nak kira, sir.
Kuat sangat nafas kau ni. Kuat sangat nafas dia. Bingit ni. Cepat, siapa dah dapat? Cepat. Rezal, dapat Rezal.
36.5 mili.
36.5 sahaja Betul
Betul.
Oh, ramai tu. 56.5 volts. Okay.
Millivolt.
Okay. Don't forget because the value is milli, so please don't forget the milli one If they give you, or you can write as a minus 0.16 also can, no problem. Okay, 0.16 also can, no problem. As soon you're not doing mistake, it's okay lah. Anything is okay, everything is okay. Okay, last. Maximum power, tak apalah saya bagi terus ini. 150 and the temperature coefficient of power minus 0.5%. Okay, so minus 0.1%. Yeah, 4 ROC of PMP ROC. So what is the equation? PMP STC apa? Cepat. Cepat.
Darat dah.
Come on. Darat. Betul.
Darat. 1 tambah.
Okay, 1 tambah PMP T-cell tolak STC. Okay, 150. Okay, 1 plus what? Cepat, siapa? Syed.
0.5.
Okay, negative 0.5. Lagi? Tu je?
Over 100.
Over 100 Don't forget over 100 And then 68.75 minus 25. Okay, please calculate. How much is it? What?
117.
117.
Point
Point
1875.
1875. Oh yo. Laju. Okay. Betul kot. 117 from 1875. Okay, congratulations. Okay, last. Conversion efficiency. If someone still remember. P out over P in. Macam nak kira? PMP ROC over G multiplied with A. Okay. PMP ROC 117.1875 over, because the STC it didn't given is 1000, but the area is not given. Tak apalah. If area is given, then you can solve it So this one you can multiply with 100, then you can get percent kat sini So A ni will be given in the question But in this question I think I not given maybe. Okay, boleh nampak. Apa ni? 700 apa ni? Alamak, sikit Nampak ni? Siapa nampak? Aku dah pun
790 je.
790, okay. Ni apa? JM mana yang besar ni?
950.
Ni.
1593.
1593. Okay, sekejap. Okay. A sama 1 point apa? 15? Oh tadi 93
Ya sir.
Ni. Okay, A. In meter lah. Ini in meter square. Okay. Remember, convert it to meter. Then, berapa dapat jawapan last? Cepat. Kira cepat. Berapa dia? Berapa ni? Siapa dapat jawapan? Cepat.
9.31%.
Berapa? 9 point?
131.
Kuat sikit. 9.31. Siapa dapat ni? 9.31. Same.
Dapat.
Yes.
Dapat Same Okay, any question? Any other question?
No, sir.
Owi boleh Owi?
Boleh doktor.
Okey Alhamdulillah. ID.
Okay, sir.
Okey Muzammil.
Okay, sir.
Okay. Okay, sorry. 4 already. Okay, so that's all for today. See you on Wednesday. And selamat berbuka puasa Selamat berbuka puasa Jangan buka lagi baru pukul 4. Okay, Assalamualaikum.